Welcome back to another video. Today, we have an interesting number theory problem. This is quite an easy one, but I intend to bring a lot of more number theory content, so this would be a good start. Positive integers a and b satisfy the equation p squared plus a squared equals b squared, where p is a prime number. Prove that 2 times p plus a plus 1 is a perfect square. Pause the video right here and try to solve it. I'm sure you'd love this problem. Okay then, let's get started. Let me start with the data that's provided to us, which is p squared plus a squared equals b squared. Using the fact that a and b are positive integers, and p is a prime, let's see how we can come up with a useful result. Take a squared to the right-hand side. We have the difference of two squares now. Factorize as b minus a times b plus a. Here, note that a and b both being positive integers, b minus a and b plus a both would be integers. In the left-hand side we have p squared, quite interesting as this is the square of a prime number. If we write p squared as the product of two positive integers, we can easily equate those two with the two terms in the right-hand side. Now, if you think carefully, there are only two possible ways to write p squared as the product of two positive integers. One way to write it is p times p. The only other way to write is 1 times p squared. P being a prime, it has no factors, hence we have only those two options. First, let's consider the option p times p. So we can equate with the right-hand side as p equals b minus a and p equals b plus a. Both being equal to p, this results that b minus a equals b plus a. B cancels off from both sides and we're left with 2a equals 0. This is a contradiction, as we know that a has to be a positive integer. Therefore, we can safely ignore the first option of factorizing p squared as p times p, and go with the second option, which is 1 times p squared. Now, we can equate 1 and p squared with the right-hand side terms of b minus a and b plus a. Note that b minus a is smaller than b plus a, hence we need to equate 1 with b minus a and p squared with b plus a, not the other way around. Now take the first equation, 1 equals b minus a, and rewrite it by subjecting b, so b equals a plus 1. The reason I got b subjected is because the final term we need to show a perfect square doesn't have any b terms in it, so at some point we need to substitute for b and remove it. Now we have an equation for b, and as I said, we can easily substitute that in our original equation. P squared plus a squared equals b squared. We get that p squared plus a squared equals a plus 1 whole thing squared. Expand the a plus 1 squared term in the right-hand side. Now the a squared term in both sides cancels off. We get the result p squared equals 2a plus 1. Now, rewrite this by subjecting the 2a term, as we'd need to make another substitution. Finally, let's look at the actual expression that we need to prove is a perfect square, 2 times p plus a plus 1. Let's expand this and write as 2p plus 2a plus 2. Look at the 2a term here. We can substitute for it from the previous equation we found for 2a. Now simplify and rearrange the terms. We get the expression reduced to p squared plus 2p plus 1. This equals p plus 1 squared, hence we have shown the expression is a perfect square. This concludes our proof. Hope my solution was clear. Let me know your thoughts down in the comments section. Then, hope you drop a subscribe to my channel. See you soon with another interesting video. Goodbye.